So welcome everybody. This is Howie Meyers' presentation of his directed research project. Howie's candidate for a Master of Science in Earth Sciences with the ocean mapping option in the non-thesis program. So in the non-thesis program, the students take more hours than the thesis students do, but then they do a shorter project as a directed research project. And so their requirement is to do the research project, write a report, and do a public oral presentation, which is what Howie's going to do today. So Howie's a 2017 graduate of the College of Charleston with a BS in geology. He was part of the BEAMS program there, which has brought quite a few folks into hydrography over the last several years. And after graduation, he went to work for the NOAA navigation response teams, doing hydrographic survey primarily to open ports after hurricanes or other natural disasters. So I'm going to turn it over to Howie.
Thank you, Andy. Good morning, everybody. Thank you guys all for coming and everybody out there in Zoom land. Again, my name is Howard Meyers. And yeah, since 2017, worked for NOAA's Office of Coast Survey, the Navigation Response Branch. And so my entire experience up until coming here to UNH has been shallow water surveying, less of the continental shelf shallow and more like scraping the bottom of your boat shallow. So I kind of used my experience to kind of influence my direction in my research here. So all right, so sorry about that. I'll give a brief introduction. So the Atlantic coast, as we know, is dominated by shallow sand bottom intercoastal areas prone to shoaling and other navigational hazards. These areas, especially in the southeast of the United States, are prone to hurricanes and other storm events, which will result in the closure of major ports due to potential shoaling, other hazards from debris. These areas must be surveyed to ensure the safe navigation of commercial vessels, but also private mariners. And the support in hurricane recovery is really a balance between the needs of rapidly opening these ports and harbors and conducting full object detection surveys. The kind of goal is to obviously get into an area affected by a hurricane or other disaster, survey and get out of there as fast as possible. But in doing so, you want to make sure that you've identified any potential detons or dangers to navigation, for example, as we see here, so that we leave with the information that the port or area is clear. So as we move through this presentation, we're going to think about what are the needs and limitations doing these kind of storm response surveys. So our platforms, our vessels need to be mobile, need to be adaptable, maneuverable, and we need to be able to be able to quickly deploy, acquire, and process that data. So we're often faced with the choice: do we conduct full 100% multi-beam coverage, or do we forgo full coverage for 200% side scan imagery with concurrent multi-beam in the middle? And so the real kind of question at the heart of this is, does a combined bathymetry and side scan sonar have a place in storm response surveying? I'll give just a brief outline, and we'll talk about a little bit more about storm response surveying, about the NOAA's NRB mission. So prior research that led me down this path, and then obviously get into my methods, results, and hopefully by the end have a discussion. So off the bat, the hydrographic survey specifications and deliverables. There is one brief part about these phase measuring systems and why that they're generally not accepted for charting purposes. The first being its high uncertainty, and the second, and what I'm hoping to tackle in this study, is that these systems may be capable of reliably resolving features on the seafloor. So again, like I mentioned earlier, the Southeast, particularly in the Gulf, really gets affected by these hurricanes and other storms. So the federal government needs to assess and conduct hydrographic survey to reopen all these ports, like I mentioned. Briefly, also talk about the NOAA navigation response team. So we have 6 teams located along the coastlines. We service rapid survey units. It will be trailered and deployed anywhere in the U.S. And we assist the reopening of ports and harbors. So while conducting, object detection surveys in shallow water, it's often acceptable to forfeit 100% bathymetric coverage and survey with set line spacing to achieve 200% side scan coverage with concurrent multi-beam data, in between. So we operate a number of these ships here, the smaller ones in the front, not the giant one in the background that's on its side. The benefit of using side scan concurrent multi-beam is obviously reduced survey time, the drawback being a lack of bathymetric information in those inter-swath areas. Additionally, having 2 separate systems on the boat means twice the time to deploy those systems, twice the time to acquire, twice the transferring, and twice the hardware on the vessel, etc. So with this topic, there's a paper that really kind of sparked my interest in this, and EdgeTech, along with the U.S. Army Corps of Engineers, did a study in Jacksonville, Florida, which is actually where my team is located, and they have some claims about the IHO special order capabilities and swath width. And so, these systems have potential for really increasing the efficiency of teams in the field, especially in shallow water. The only issue with this paper that I found was that there's no mention of the object detection capability. I found this to be a real opportunity of study, right? And so you can have the widest swath width that you can, but if you're not able to identify targets and produce least steps on those targets, then hurricane type surveys, storm recovery survey may not be the best application for that system. Additionally, these 2 other papers I'll mention briefly just because I used their methods to adapt and use in my own study. So speaking of methods, as we start to think about designing a test, there's a couple of questions that we want to answer. How can we create these post-hurricane environments? How can we simulate a typical destruction found on the seafloor? How can we manufacture a target that can be deployed and then recovered off the bottom? With what is known about the EdgeTech 6205 combined bathymetric and side scan sonar, how can we design survey to test the target detection capabilities and gain further understanding of the system's binning methods? So what is a binning method? Essentially, this combined bathymetry and side scan sonar takes a number of measurements in its full field of view. To generate soundings that can then be processed, they have to bin their data into a set distance. So there's 2 ways that they'll do that. They'll bin their data based on distance, so set spaces on the seafloor that will then be used to generate soundings, and then also by angle. So a set angle that you can think of as a beam from your typical multi-beam. So first off, how can we generate these post-hurricane environments? They're typically areas that we see shallow, maintained channels, sand and mud bottom. So this area off of Long Sands Beach was chosen. Shallow sand bottom, gentle slope, protected from some north winds. what's going to simulate a typical obstruction found in the seabed. So we showed this image earlier, and what we're seeing here is a DTON report, Danger to Navigation report from 2018, a hurricane response due to Hurricane Florence in North Carolina. I was part of this survey, and so as we see here, right in the middle of the channel, we had a 2-meter vertical target and a maintained channel of about 13 meters. And this was surveyed, probably seen, I forget what this ended up being exactly, but this was probably seen in our side scan and then surveyed again with multi-beam to get at least depth. So what we ended up doing was recreating 2 different objects that we can deploy on the seafloor to test. We have 2 targets, total heights of 1 meter and 2 meter, constructed with wooden 4x4 posts set into a 5-gallon bucket of concrete, rigged to be able to be deployed and recovered using the RBGS's A-frame. These wooden piles represent, possible objects that may be found in a post-storm environment. So examples being sunken tree trunks, limbs, debris from docks and marinas, so on. So the goals of the survey, we want to be able to test the target detection. I'm going to keep saying that a lot, but we want to test how this system can identify and collect soundings near nadir and in the outer swath. We want to test each binning method for how it filters that data, how it turns those raw measurements into soundings, and if those soundings represent accurately the target which was surveyed. And we want to test the effects of the default water column filter on those detections of that vertical target. So the binning methods. So EdgeTech has 2 separate ways to bin their data, which are then available for the end user to then process. So the first is distance binning, which uses equidistant sections on the seafloor. These are defined by the user in the Discover bathymetric software during acquisition. And then within those bins on the seafloor, a weighted average is taken to produce a sounding. The other option is a equal angle bin. You can think of this as a beam from your typical multi-beam, even though it's not exactly. This has equiangular bins that again will be used to produce those soundings. As it's equiangular, this does not have a evenly distributed pattern on the seafloor. And so you'll have less dense data, further away from the air. So in designing our tests, we want to test all of these variables. So we created up 6 tests. The first 2, we have our water column filter on, and we test the equal distance and equal angle binning methods, and then 3 and 4, we turn that water column filter off to see how it reacts, again with the same equi-angle and equidistant bins. So at long stands, we deployed our targets at equal depths. We set a line plan and high pack to be directly over the target, and then at 5 meter intervals on either side. Just briefly here, so schedule for the tests, we mobilized the RV Gull Surveyor. We had the EdgeTech 6205 on the center strut of the vessel, and a Contour 2040P on the USM pole mount on the port side of the ship. Collected our patch test. We did some preliminary testing and some test deployments of our targets, and then finally transited to long stands. Did our multi-beam survey over the targets, and then conducted our tests with the EdgeTech 6205. So as we go through our results, what we're looking for here is how the settings affect the resulting soundings recorded in the JSF file. So a JSF is the native file that EdgeTech, that the Discover software writes, and so you'll have your binned JSF file is what is being recorded. We want to see is the sonar to detect the vertical pile with any regularity. Then we want to compare the known height of those two targets, the 1 meter and 2 meter targets. Compare those heights to the shoaless sounding for each test. So I'm going to show you the results from the process bin data from what we actually collected in the field. Additional to the bin data we recorded was called a raw staved file. Essentially what that is a staved file is a diagnostic file that you can record. It's used by EdgeTech, but it can also be used to recreate and rebin the data with whatever settings that are chosen. So it's a way to collect one set of data and then reprocess that with a number of different settings. And then additionally, we're going to show results from another binning method. So as expected, our multi-beam survey clearly shows the base of our target and the vertical nature of that pile. What's important to note here is that a standard 5-gallon bucket is about a third of a meter tall. Measure the bucket and our base to be about 0.4 meters. So we're going to infer that anything above that point is going to be any soundings above that point is going to represent measurements that are taken on the actual pile itself. So I'm going to kind of breeze through these data. There's a lot of tests, a lot of different survey lines. I'll do my best to point out as we go the important things. And at the end, we're going to we'll touch on all of it. So the test one, again, this is our equidistant binning method water column is on. And so we see here pretty uniform results, clearly identifying the base structure. As we see here, base, 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 base. But there's no soundings on the pile. All of our measurements are this 0.38, 0.37 meter mark. Our 2 meter target, we have one complete miss here. And then on the other tests, we see some shoulder soundings. We have a 0.5 and a 0.6 above the seafloor. And I apologize if it's hard to see, especially on Zoom here, guys. But we have our pile, and we have some soundings directly above it. While this is a 2 meter target, and the maximum relief we see here is only 0.6, so we're just not getting an accurate representation of that pile. Test 2 is the exact same line plan. However, we're using the equi-angle method this time. I start to use these red boxes around the targets because it gets a little bit hard to see, especially with the increased noise that we're going to see. But there's much higher variation in the total relief. There's again no real representation of that vertical pile. Move on to our 2 meter target. We do have one pass that shows a total relief of about 0.9. But in general, what we see is that we don't see a clear representation of that vertical pile. And with the change to the angle binning, we see an increased noise. So there are some, drawbacks to that equi-angle method. We might see better representation of that pile. However, we see a lot of, in that equi-angle binning method, we see a less density of soundings here at nadir, and again, increased noise, which is going to increase your uncertainty. So tests 3 and 4 were again just repeats of tests 1 and 2. They have the water column filter off. I'm going to go through this quickly here, but soundings generally are less dense and less coherent on the targets. Our 2 meter target here. We again see a lot less dense data here at nadir and increased noise. Test 4, back to our distance bin. Again, we see a lot more noise and it becomes challenging to pick out the actual base of our target with this nadir noise that we see. If we were in the field and this is the only pass that we had, I think it'd be hard for a field unit to identify this as a target compared to this next to it. this is just showing here on the left, just a summary of all the data. But what I'm gonna make a note of here is that with the settings that we had selected within Discover software, no tests were really able to resolve that vertical pile. The equal angle binning tends to increase the noise level and decrease the soundings density of nadir, and the water column filter essentially had no benefit to detecting the pile. I mentioned earlier that we can record what's called stave data, and so a stave data set file is an additional file that you can record as you're recording your bin data. So your bin JSF file is what you as the consumer, what you as the surveyor would come back and process. That data has been binned, and there's no way to change that binning method once it's been collected. Stave data, so a stave JSF file is essentially a diagnostic file that is used by EdgeTech. This file contains all the raw measurements, all of your range and angle measurements from the sonar, and can be reprocessed by EdgeTech for whatever binning method that we choose. And so I'll point out here, this white data is the raw unbinned data, and this yellow in the middle shows the reprocessed bin data. And so what's interesting here is that while we see, and it's probably hard for us to see, but the maximum binned data stops right about here. The system itself is resolving the vertical nature of that pile, but it's not being kept. It's being essentially filtered out when it's being binned. I'll go through some tests here. So near nadir test for our 1 meter target binned. So it's the exact same data binned with our equidistant and our equal angle methods. So this data was binned to an 8 centimeter bin for a distance and a 0.25 degree bin for our angle. And we see here that the raw data maximum relief is only about 0.4 meters, and that's seen in both the equal angle and equal distance methods here. Interestingly, our 2 meter target is represented very well in the raw data. This white data here shows 1.8 meters of our 2 meter target. So it's not quite perfect, it's still 0.2 meters different. But we see that the system itself is capable of detecting that pile. So for our distance spinning method, we resolve only about a 0.8 relief of that target, but our equal angle method here resolves a 1.4 meter relief. So significantly better than the distance spinning at nadir. So again, we see the white is our raw unbinned data. This yellow here represents the distance spinning. Exact same data set, but binned now with our angle binning. And we see that just that switch from distance to angle, we now see a total relief of 1.4 meters. So that was near nadir. Now moving out to our outer swath, this is about 74, 75 degrees from nadir. And the difference that we see here is that due to the equiangular binning method having significantly less data, much larger bins on the in the outer swath, the pile, the 1 meter pile is completely missed here in the outer swath, though it is somewhat resolved here in the distance method. This is the same for a 2 meter target. Again, whereas near nadir, the equiangular method resolves the height of the pile a lot more. In the outer swaths, this equiangular method does not produce any soundings on the target. All right, so here. So no soundings on the angle, and then soundings on the distance. So the next bidding method, or method for generating soundings, EdgeTech has been implementing it. This method was first produced by Val, Thomas Weber, and Xavier Lurton. They call it their BTX method, which they derived just from the names of these authors. From this paper, this method aimed to produce statistically independent soundings, and the number of measurements that are combined to derive a single sounding is directly related to the uncertainty associated with those measurements. So areas of high uncertainty, such as areas at nadir here, or measurements on our pile with a low signal to noise ratio, we find are still represented with this method. But because there are more measurements that need to be taken into account to combine to an uncertainty under the defined threshold, this results in a much lower data density in these areas. So this is probably really hard to see. I'm going to change slides here. So as you see, that full 1.8 height that was resolved in the raw measurements is depicted here by this BTX method. So that full. What else happening now? So
for those of you online, Val is cheering.
So it's obviously not perfect just yet. This data is quite sparse. EdgeTech is, I think, just in the first stages of implementing this method, but it does resolve full height and produces soundings from those measurements that depict the full height of that target. We see some not a lot of soundings here at nadir, no soundings here of the actual pile, but the fact that we can generate soundings accurately on the fully observed height of the raw stave data, I think is important. This is a little bit less nice of a slide, but as we see, the raw data only picked up to about that 0.4 meter mark. Again, that's just the height of the base of the target, the bucket, and the base. And because of that method, needing to combine a lot of measurements that have a high uncertainty to generate these soundings, these areas, especially at nadir, where there's much higher uncertainty, has much sparser data. So with that, those are the three real results from the method. We have the bin data, the reprocessed stave data, and this new BTX method. I think there's a lot of positive and encouraging takeaways from this study. EdgeTech, the 6205 has the ability to record measurements on what's really a challenging target. Multi-beams today have trouble picking up those targets. It's often that we see something in a side scan and have to rerun lines over it to collect at least depth on it. It's clear, I think, that the acquisition settings in Discover Bathymetry that might be selected for a standard hydrographic survey are not optimal for the object detection part. When you compare the results from the first binning methods with the reprocessed binning methods that used a really strict, tight bins, it's clear that what you might use for a standard survey is not going to be as optimal for detecting these kind of targets. It's positive that EdgeTech is working on alternative methods for generating soundings. I think they understand that this is a limitation of their current system, and this BTX method I think is going to be continued to be developed. So to tie it kind of back to storm response surveying, there's a lot of potential benefits of these phase differencing, combined side scan bathymetry sonars. Increased swath obviously would allow a survey vessel to keep more space between the vessel and hazards, docks, piers. There's obviously a potential time cost benefit. However, I think the study demonstrates that for the time being, there's a present need for multi-beam to collect accurate least depths on targets. I think that with the current bidding method available to consumer, and not being able to change the binning method after that data has been recorded. Survey teams are going to really need to rely on that multi-beam for now. They're not going to be able to record at least that measurement on an obstruction with any confidence. I think in the future, it's going to be really important for us to think about, how that data is used by the consumer. I think a method for consumers to reprocess unbinned data to suit their own needs, being able to change between that angular and bin method would be a big step. And I think, I'm looking forward to seeing, the future of this PTX method. So with that, that's basically what I have for you guys. I want to thank Andy, obviously, Andy Armstrong for his guidance. I want to thank Senlot and Val for their time, Captain Matt and Dan, RBGS, and everybody else here at CCOM. Big thank you to NOAA's OCS for allowing me the privilege to come here and study for these past 2 years. Thank you to EdgeTech, Richard Hill and Kevin Reichert for their support, and then I'll give my wife a shout out for being 7 months pregnant and without me. So with that, references and thank you. Questions?
That was super interesting. I was just wondering, with that VTX method, I don't know how you guys process data when you're responding to storms and things, but would the idea be that you have some toggle and you basically switch over to the VTX binning method in a less uniform, in that type of environment?
Yeah, so I think this comes back to the interesting bit about being able to collect your data once and then reprocess it how you would like, right? And so that's currently not available. You select in the Discover software, you select how you want to bin your data, and then you get out that bin JSF file. And that's all that you're given. The stave data is only able to be processed by EdgeTech. It's something that only they can handle right now. And so I think, in the future, it'd be great to be able to say, all right, I know that I can accurately depict, these targets in whichever method it is, right? I want to survey and then reprocess a part of that data to then depict that target. So I think that would be a way to do it in the future.
You can actually reprocess the state data yourself through Discover, but you have to replay it through Discover, and I think the bigger challenge is that the files are at least an order of magnitude larger in size, so it's really difficult to manage and to consume all that data.
And again, in a storm response environment, it's time, and so it might just until it's time more efficient to do it that way than to just run your typical multi-beam with your side scan.
Is that what you guys are doing right now?
That's it depends a little bit on the depth and the environment, but we find, especially in the southeast, it's very flat, very shallow. We find that 200% side scan coverage with concurrent multi-beam is the most time-effective way to do it. Also, you have the side scan data to really make sure you're not going to miss anything.
Totally. Thank you.
Daniel, or go Val.
All right. Yeah, this was terrifically presented. I thought it was great. I do have a couple questions. When you ran the EdgeTech lines, what did you set the range setting for that? The total swath width? Was it set as you would set for running side scan, or set commensurate with the water depth and a
the side scan lines, we ran set line spacing for side scan at 50 meter range scale. But my understanding is that for the bathymetry, you're collecting the full 200 field of view at all times, and then that data is then cut off. You have gates, so that data is gated, and then
you're absolutely right. So my next question is, how do you suppose the ping rate of the EdgeTech 6205 compared with the multi-beam while you were doing those surveys? And do you think that might have affected this at all?
I do. And again, I would be really curious, and unfortunately wasn't able to get a hand on the 850 kilohertz system. I think that would have been the next test to do, would be to test that higher frequency system. I think the ping rate. Yeah, I think that's something that I probably didn't think about enough going into the survey. I think that it's set based on the range settings, and I had a brief discussion with Kevin and Richard about it, and I think that I forget what came with that discussion, but I think that there was potential for a higher ping range to be used. And yes, I think that a higher ping range would have potentially had more soundings, more measurements, on the target.
Yeah, I think what we found is that like the dream would be to have a really wide swath and to only have to hit every target once.
Yeah.
But the reality is that you can have a really wide swath of 6205 and use the side scan and the bathy to detect targets, but then you need to bring that range in to up your ping rate and then go over the targets and quantify it in the way you would a multi-beam, and then get a better chance at least of catching the least.
Yeah, I agree. And so that's kind of comes down to is there a place for that specific type of survey? Because you obviously in these storm responses have your side scan. We use a 4125. So you're always going to be coming back to make sure that you can detect that target. The question I think is you come back in for a multi-beam. You want to hit it right at nadir. You want to get your best soundings over it. I think the question for this was say you were to come back and do that, not have a multi-beam, not have a Coxbury, but have just this one system. Are you going to be able to do these exact same type of survey, come back and really detect that target? And I don't think that these results really say that we can just yet.
Thanks.
So you clearly show the relative advantages and disadvantages of granular versus distant. But when Codesburg was developing things, they also came up with an in-between mode. But it's a nice compromise that spaces the beams closer together near nadir. So it's basically and so I wonder if that, from an EdgeTech evolution perspective, that they may consider.
Yeah, so I agree. I think like I've shown the detection capabilities of the angular mode are much better at nadir, but totally miss only outside. So I think that if I was EdgeTech, if I had the say of what happened, I think that some sort of in-between mode would be a good option. Or again, just have the ability to reprocess that data and say, okay, in this line we see it, but it's not the full height, or we totally miss it. We know it's there, but we totally miss it with what we had. Let's reprocess it with the other method. So I think there's kind of maybe the two ways that you could go about it.
Daniel.
So I remember the field worker troubleshooting the data. Can you just explain me what was the final answer of it?
It was so we had some issues bringing in the pause data right from the actual EdgeTech, and weren't able to basically have positioning until we applied our SBATs. That was a combination. I think that was a setting within Discover. There was one of the drivers I think was wrong. It was just a setting thing. Yeah, it was a me thing, not a EdgeTech thing.
It's always next.
It's always us.
I have another question. It's more about like operational. So after storm, you go there, just let's survey it. Let's make sure that it's clean, that the boats can, vessels, whatever, it can just pass by safely. Do you guys have a looking forward sonar also, or no?
No.
Oh, and
I get, you know. I get what you mean.
Yes, why not?
We don't have one.
I'm just wondering, like,
We don't. I don't know if it would benefit us too much. And again, you know, we're adding a lot of different things on the boats. It's a lot going on as it is with a side scan and a multi-beam. A forward-facing sonar, you know, might benefit us to, one, obviously not hit something or, you know, get close to it.
I'm just worried about you guys, the boats.
Yeah. No, there's been a couple, you know, scenarios where, you know, there's things that are, you know, right under the surface or things that are, you know, potentially hazards.
Okay.
We do our best to, you know, be cautious and again run with our, you know, side scan so that we can see, you know, hey, there's potentially a hazard, you know, to our port side. Let's not drive over it right away. Let's get a, you know, a shadow measuring on it. Okay, it's not that deep. It's fine. So there are some hazards, but we're generally good about not encountering them.
Thank you.
Yeah, sure.
Chris, does anybody online have a question? No questions?
Congratulations. Early.
Barely?
So you pretty clearly showed that the 6205 didn't really resolve the 1x1, which is the requirement for object detection.
Yeah.
But it does when you process it differently. So realistically, side scan is often used for object detection because it's more capable of resolving smaller objects than multi-beam is. And in this system, it seems like that's not the case. And it also gives you, I believe, you didn't go over this, but less resolution than a multi-beam system. So I'm kind of just wondering what the advantage is that it's a combined system.
Yeah. And so let me just, so that was kind of one of the main points, right? Is that if this, you know, could accurately detect, you know, least depth on these targets, we could essentially do away with having two separate, you know, a side scan and multi-beam. Even if we still had to do the exact same process of seeing it in the our side scan and then coming back to collect least depth on it, we do away with having two separate, you know, things on the boat. So that was kind of one of the main points.
It was interesting that it was less capable of resolving it in the far
Outer squads.
rather than the near nadir, which is
That
not
was
necessarily the opposite of side scan, but kind of the opposite.
that was again because of so the angular binning method. One, so the distance bin, right? You have something on the seafloor, and then you have a target. It's taking all the data from that, you know, width and basically compressing it and taking a, you know, weighted average to make a sounding. So it's going to compress that data. So in general, the distance method is going to not resolve those, you know, piles as well. So that's why it didn't do as well near nadir than the angular mode. However, because the angular mode is basically, you know, an equal angle, you know, it has tighter bins, you know, near nadir, and much sparser data, much wider bins in the far field. And so that's why it totally misses, you know, that pile out to like 75 degrees, which is where it was.
Yeah.
I think you have to be a little bit careful about how you characterize that. Like, the system has a potential to provide much higher resolution than a multi-beam if it's processed right. There's another filtering bit there that happens that maybe you know about, maybe you don't, but certainly for the equal cross-track distance spinning, they pass a medium like outlier filter across all of the data. So that I would almost expect that to, I don't remember exactly the constraints of that filter, but that filter alone might have rejected the spire. And you're absolutely right. Like they're splitting the seafloor up into horizontal bins, and then all the soundings vertically in the water column within that horizontal bin are getting squinched down into one sounding. So that's going to kill your ability to see stuff up in the water column most of the time.
Yeah.
I'm kind of surprised that the equal angle stuff out to the side didn't pick it up, but
Well, equiangular performed better.
At near nadir,
Nadir.
whereas it missed on the outer side.
Yeah.
And that was up to about 75 degrees. That was just significantly out there.
It is possible to tease apart their data file and figure out which filter rejected the different bits that went into the.
Yeah.
And that might
Whether
be.
it was the median or the just like a quality flag filter, or if it was cut out and then there was nothing there for the bin to see.
Yeah.
So again, there's all stuff that I think really
It looks to me like, EdgeTech spent a lot of time trying to get around the early days of noisy measuring sonars.
Yeah.
And did a great job, just did too good a job. Yes, you can see in the raw data, a lot of that signal was there. And so I think they just, I think now with the results of what you'll tell them that they gotta go back and rethink.
and I
So
think
maybe it's worth putting out a little higher.
it's encouraging, I think, that the raw measurements, saw that pile.
Sure.
It didn't get the full 2 meters, it got 1.8, but it's there. It's just not being given to the user through those different ways to benefit.
I bet Damon Wolf, who was the author of one of those papers that you showed, a beer that he couldn't find a paint can in 6 meters of water. And he found one, but he reprocessed the data and knew what he was looking for, and he could see it. He could see it in the data. But like as you, I think, pointed out, like if you know it's there, it's easier to pick out.
Yeah. There's a lot of data where it's it's there, so it's there, but there's a lot of other stuff next to it. And Haley, kind of back to your point, it's interesting that most of the tests resolve that the base is almost a half meter cube, so I mean it resolves that. It's only the real the 4x4 posts that it has a hard time seeing. So for whatever standard you're going for, half meter cube, what's seen.
Right for machine learning.
Whatever.
Do you mind clicking back to, I think it was the 2 meter, you had red boxes around, it was earlier on, the 2 meter piles.
For the save data or for the binned data?
I think it was the bins data. Might be sure.
Or if it was a 1 or 2 meter test?
It just looked like there was kind of like not shadowing, but like an identical, yes, right here. Sorry, it was the 1 meter target. In the third image down, like you're identifying in that red box.
Yeah.
That's nadir. Okay, cool.
Yeah. So again, I know
It makes it pretty hard to pick out a 1 meter cube when you got a 1 meter of.
you got probably a whole meter of stuff up here, this big noise, and this the actual target.
Cool. Okay. Thank you.
Yeah, I agree. That's one of the points. It's like you change all these settings, so water column is off. We're in distance spinning, and if you didn't know that was there, it'd be hard to like disseminate that it's totally.
It's interesting that you get nadir noise in that image, but you don't really get it in the other images.
Yes, that was.
Yeah.
What do you mean, like just in different lines or?
Yeah, I think the point is we don't see that much nadir noise in those other ones.
Here or here,
Yeah.
I think it's just the.
The relief, that's
So it's the exact same,
exact same settings.
it's like the exact same setting, exact same pile, just different, basically passes over the target. So it could have been,
Maybe it amplifies something when it's
it's just a random.
I don't remember exactly how that water column filter works, but I think they basically made a single beam out of their sonar and tried to detect nadir right beneath it and then omit stuff above that.
Oh, if it was a single beam, is it, depending on the angle of the beam, it could be picking up. If you were close enough to it, the single beam could be picking up the pile.
Possible.
Okay, So if there's no further questions, I think we'll, thank Howie and congratulate him on running.